Today we start off on page 41 with reflections. So if we can turn to page 41, we'll get started on our objective. So today we're going to actually be performing some reflections and looking at notation that we need to know what we're supposed to be reflecting and where we're supposed to be reflecting it. My phone's a little off here. So our objective on page 41, okay, the date is going to be the 2nd. Our objective is to identify information from function notation and perform a reflection. So the first thing I want you to do is I want you to take a marker and I want you to make a grid, a coordinate grid, Cartesian coordinate, on the bottom half of your page here. So I'm going to take, and I'm going to do right here, make sure it lines up on the line. Alright, and then I'm going to take and I'm going to do one line this way. XY. Right. So, I'm going to put one other line on here, and I want you to use a different colored marker for this. I'm going to put the line x equals y. I'm going to put two other lines on here, I guess. Line x equals y. I'm going to put the line 1, 2, 3, 4, 5, 6. Y equals 6. And I'm going to put the line x equals 1, 2, 3, 4, 5, 6. I'll do -5. So I'm going to put those 3 lines on. Use a third color. And let's put some points on this here graph. I'm going to put point A, point B, and put C. I'm going to put D. So, A, I'm going to write up here where these points are so that you can see them. Okay. A is at -1, -5. Excuse me, -1, this should be 5. Yeah. -1, 6, sorry. -1, 6. B is at 1, 2, 3, 4, 5, 6, 1, 2, 3. C is at 4, -2. And D is at -8, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yep. Okay. So those are my points. Now I'm going to perform some reflections. And I'm going to show you how we perform those reflections. So the first reflection I'm going to perform is the reflection through the y-axis of A. Okay. So to perform this reflection, I'm going to start at A, and I'm going to count towards the y-axis, 1, and I'm going to count past it the same amount. So 1, 1. There's A prime. So this would be 1, 6. Something a little bit more complicated, maybe I'll do the reflection in the x-axis of D. 1, so I'm going to go down to D, and I'm going to count to the x-axis. 1, 2, 3, 4, and I'm going to count the same amount past. 1, 2, 3, 4. So there's D prime. And that would be -8, -4. Let's get a little bit more complicated. Let's say I want to count, or I want to reflect in the line y, or x equals y. Say I want to reflect C. So that means I need to count perpendicular to x equals y. So x equals y has a slope of 1 over 1. I'm going to write over here slope of 1 over 1. The perpendicular slope would be going the opposite direction, so -1 over 1. So I'm going to count up 1 over 1, up 2 over 2, up 3 over 3. So if I did 1, 2, 3, 1, 2, 3, that's how I would get to that line using a perpendicular slope. So now I want to go past that line the same amount. 1, 2, 3, 1, 2, 3. That's where C prime would be. So C prime ends up being -2, 1, 2, 3, 4. Okay. Let's do another. Let's reflect B in the line y equals 6. So I'm going to reflect in the line y equals 6, B. So this little r means reflect. This is the line I'm reflecting in. This is the point I'm reflecting. Okay. So in B, I'm going to start at B, and I'm going to count towards y equals 6 in a perpendicular way, and then I'm going to count past. So 1, 2, 3, 1, 2, 3. There's B prime. So B prime is going to be 3, 6, 9. It's going to be 6, 9. Okay. Let's say I wanted to work backwards. Suppose I gave you the image of a point. Remember, the pre-image is A, B, C, and D. And let's say I gave you the image of a point. Say I gave you C prime prime. And I asked you, what line is C reflected in to get C prime prime? Well, I want to go between C and C prime and draw a straight line. Then I want to find the perpendicular bisector of this straight line. So I go halfway across, there's halfway, and this would be my perpendicular bisector of that straight line. This happens to be 1, 2, 3, 4, 5, 6, 7, x equals 7. So what we notice is the line of reflection is the perpendicular bisector of the segment connecting the image and the pre-image. So that's something that we should make note of. The line of reflection is the perpendicular bisector of the line segment between the image and the pre-image. So let's test to make sure that this is true. Let's go back through some of our other ones and see. If I were to draw from C to C prime, is x equals y the perpendicular bisector of that line segment? It does appear to be that way. If I were to draw from B to B prime, is y equals 6 the perpendicular bisector of that segment? It does appear to be that. And if I were to draw from D to D prime, is the x-axis the perpendicular bisector of that segment? It also appears to be that way. Okay? So the basic idea here is that when we're reflecting, we start where the point is, we count in a perpendicular fashion to our line of reflection, and then we count past the same amount. Okay? And the line of reflection is the perpendicular bisector of the segment between the image and the pre-image. Okay? And we can see that in all of our transformations.